Welcome you friends. Now I am going to discuss with you the automata and its power. As the term automata suggests that something is related with the machine. Now we see what this automata. So first of all, I am going to start the automata. I simply want to ask with you one thing, that when you listen the word automata, what or which type of thought comes in your mind? The simple thought which comes in your mind is that something is related with any types of machine. Yes, in theory of computation also, automata is related with the machine. But which type of machine we will learn in theory of computation, we will see later. So let's start our topic. The mathematical representation of formal language is called as automata. As here you see the mathematical representation, okay, of formal language. Formal language I have discussed in my previous video. If you not know the formal language, you watch my previous video of formal language. It's called as automata. Okay, this is nothing but the representation of formal language. Based on accepting power, the automata are classified into 4 types. One thing which we need to remember is that there are 4 types of grammar based on production. Okay, as here you see 4 types of grammar but based on production, but there are 4 types of automata based on accepting power. Okay, clear this thing? Yes. So first automata is finite automata, which accepts the regular language, which is related with the regular grammar. Okay, in the same way the next is to be accepted by this pushdown automata, which is related with the context free language, linear bounded automata, which accepts the case sensitive language, and tuning machine, which accepts the regular enumerable language. Now we see the chart here that regular language or finite automata is on the center of this circle, and context free language or pushdown automata covers the regular language. It means some language may remain which is not on the CFL. Is this true or not? No. It means some language which is not on the CFL may or may not be on a regular language. Like if we have X, we simply take, I just take a pen. If we have A, is this A on CFL also? Yes. That means those language which is in a regular language must contained by CFL or PDA. In the same way, if we take another language like B, is this language B is on CFL? Yes, because this is the B is in the bound of CFL. But is this language B is on regular language? No, because B is outside the regular language. In the same way, regular language and CFL both comes under the CSL, and in the same way, CSL, CFL and regular language comes under the REL. Advanced tuning machine is a machine which accepts all the language, either REL, CSL, CFL or RL. And reverse is not true. Okay? Reverse is not true. Now we see accepting power of automata. The number of language accepted by an automata is called as accepting power of automata. Accepting power of finite automata is 1. Why? Because it only accepts the regular language. In the same way, accepting power of pushdown automata is 2. Because it accepts both regular language and context-free language also, as we see before on the circle. In the same way, linear bounded automata accepts regular language, context-free language and context-sensitive language. All. In the same way, tuning machine accepts the all language, regular language, context-free language, context-sensitive language and regular enumerable language. Here E stands for accepting power. It means accepting power of tuning machine equal to 4. RL, CFL, CSL or REL. You understand why accepting power of a tuning machine is 4? Now let's see. Let M1 and M2 are two mathematical models such that accepting power of M1 is greater than M2. Then M1 is more powerful than M2. Okay? Because the accepting power of M1 is greater than M2. Then this symbol suggests that M1 is more powerful than M2. In the same way, we have the point PDA is more powerful than FA because its accepting power is 1 and its accepting power is 2. And in the same way, LBA is more powerful than FA or PDA. And in the same way, tuning machine is more powerful than FA, PDA and LBA. Okay? Now let's see. Now we see the different types of automata and its accepting power. In regular language, the language accepted by the finite automata, and there are two types of finite automata, DFA and NFA. The accepting power of DFA is equals to accepting power of NFA. It means DFA and NFA both have the same power. In the same way, in context-free language, we have studied about the PDA, and this language is accepted by the pushdown automata. And pushdown automata have two types, DPDA and NPDA, which means a deterministic pushdown automata and non-deterministic pushdown automata. But the main thing is deterministic pushdown automata is not equals to non-deterministic pushdown automata. As we have studied that DFA is equals to NFA, but DPDA is not equal to NPDA. But here we need to understand one thing, that DPDA is 100% converted to NPDA, but every NPDA is not converted to DPDA. It means conversion from DPDA to NPDA is 100% true, but from NPDA to DPDA it may or may not be possible. Okay, this was about the context-free language. Now we see the other language. In context-sensitive language, we have studied about the linear bounded automata, and the language accepted, context-sensitive language is accepted by the linear bounded automata. Linear bounded automata also have two types, and DLBA or NBA. Sorry, NLBA. Okay. It means deterministic linear bounded automata or non-deterministic linear bounded automata. And about the power of, or about the accepting power of DLBA or NLBA is still on research. It means research is going on about the accepting power of DLBA or NLBA. Now we see the regular enumerable language. This language is accepted by the Turing machine, and Turing machine also have two types, DTM or NTM. DTM means deterministic Turing machine or NTM means undeterministic Turing machine. And both the Turing machine have equal power and its accepting power is also equal. So that's all friends. So please subscribe to my channel for more update and for more video of theory of computation. That's all. Thank you.